Hey everyone, it's me, Steve. It is April 6, 2018. Time's about 12:05 and it's 35 degrees Fahrenheit out. And it is Geo Rant time. This was actually a special request by somebody, so I prepared some slides. They're not perfect because I did go through them pretty quickly. But Grabens, well, what are they? Well, graben, this is basically from Wikipedia. It shows the mechanics of a graben. If you look here, you can basically see the arrows are relative movements, and this part right here is a fault. This is a fault plane. That's fault, fault, fault. And this represents a series of horsts and grabens. Like I said, the arrows are relative movement. And what forms a graben always is continental extension, which is represented here. The crust extends and you get a graben type situation, with sometimes with horse, sometimes without. It isn't always with horse. And you can get half grabens, and you can get things like grabens that are stepped but nothing on the other side, and rotation and all that, but I'm not going to get in any of that. I created a simple model for you. It's to show you what can cause continental extension. And here's just a cross section. These are just layers of the earth, no particular thickness or scale, all right? So then one thing that can happen is a magma can start rising through the crust, causing the extension. You start to get faulting as the crust compensates for the spreading and moving apart. Something's got to happen when the crust is moving apart. It's just not going to get thinner and thinner and thinner and thinner until the magma pops out at the surface. That's not what happens. So you start to get cracks, which develop into faults. And the arrows here the black arrows represent relative movement. Crust is still extending. Magma chambers moving up. And eventually what happens is, as extension continues, we start to get volcanoes, and my little volcanoes there, and extension still going. The magma chambers pushed up, the graben is pushed down, and we've got our little volcanic activity. So that's the traditional way of how a large-scale graben forms, like the Basin and Range province, which I'm going to get into here in a few minutes. But this guy's next few slides are from this guy's blog. He actually has a lot of good slides, and I put the reference down here just so you can go to see them. And the good thing about this guy's blog is that he actually cites where he took stuff from, which is good. And so I'm going to start talking about the Basin and Range, because this is an area of North America that has been under extension for millions of years, actually widening the continent, and we're not really sure what's going on. Now, just here, this is from that guy's website. You can read it if you want. It's a profile across Death. We're going to be talking a lot about Death Valley here. Now, here is a Basin and Range formation from crustal extension, showing different types of grabens and faults that can form within the Basin and Range. All right, I am going to show you where the Basin and Range here is in a minute. But in reality, on the ground, that's textbook stuff, and what I've been showing you is pretty much textbook. In reality, on the ground, it's going to look something more like this. Okay, so you can read that if you want. He also included how the Basin and Range is affecting groundwater. So I just took this. This is just kind of cool information, so you can read that if you want. Okay, so where is the Basin and Range? Here. There's the Basin and Range. I'm still in that guy's blog here. Stuff I pulled from there. Read that if you wish. All right, as you can see, he's got extension here, and he's got the location of Death Valley. All right. Here's a zoom in, of Death Valley. I'm gonna read that. Go ahead. Now, this I made. Okay. This is a Google Earth map. This here is something I did really quickly. I've outlined the Basin Range. Here's there's this part there that should say legend. It got cut off. Sorry, I apologize for that. I don't know why it did, but the yellow outline is a Basin and Range. And what you see if you look over to the Pacific, here's San Andreas Fault, which everyone is aware of. You still see there's rifting going on up here, the East Pacific Rise, which this got cut off here too. You can see a little bit of it, and down here. So basically what we have is we have a rift here and a rift here, a subduction zone right here, these subduction zone right here, rifting, subduction zone, complex transform faulting here, and extension going on here. This is a lot of stuff going on and there's a scale right there for you in this small, relatively small area. So this is the rifting here and here is known as the East Pacific Rise. And the East Pacific Rise is one of the fastest spreading centers on the planet. It's faster than in even the Atlantic, all right? I find it very hard to believe that as the North American plate rode over this, that it would shut it off, all right? There haven't been any really deep seismic studies done to determine if there are magma chambers out here, but there are volcanoes. There has been volcanic activity here. So that could just have been a side effect of one plate sliding under another and causing friction and popping up some volcanoes. That is a possibility. I don't think so, though. Personally, and this is still hotly contested geology, I think the continent is trying to split here and reestablish the East Pacific Rise. And you kind of see sort of triple junction-y type outlines within the Great Basin, as if it's trying to rift. Now, will that be successful if it is what I think it is? I think probably. But you're looking at 50 million years down the road. So I don't think that this is just a fluke. I mean, yeah, you have subduction here, but the subduction, if the rift comes back up over this way, which I believe it is, you can still have subduction here, and eventually it will go under the continent, and then you'll extend the rift, and the rift will reconnect to the East Pacific Rise, and subduction will cease. We know subduction stops. It's not a forever ongoing process. So that's what I think what will actually happen. And there's a couple good theses and dissertations out there if you want to read stuff in detail. Here's one of them right here, so you can look at that if you want. All right. There's another one here, and I'm going to show you a couple. So there have been seismic profiling has been done, and this one has some of it in it from 2009, and I'm just going to show you a couple of those. But and these are free online. You can go in and Google them, and you can find them. Here's some seismic profiles. Page numbers are on top. And this is a good one, because this one goes all the way down to the Precambrian basement. So there's that one. So, in a nutshell, to sum this up, grabens form through continental extension. All grabens. All right, we know that, okay? Just the mechanism of how it forms can be somewhat questionable or in dispute. Like, magma chamber, we know that does happen, because otherwise we wouldn't have plate tectonics. But is the basin and range that type of thing? I think it is, but many others don't. I mean, you do have that convolution of complex transform faulting going on. You have subduction, you have rifting, all within that small area along the western half of the U.S., or western third. So it's complicated, to say the least. But anyway, please like and subscribe if you haven't already. If you have any questions below, I will try to answer them. And I think that's it, and I hope you learned something.